This week's quiz is going to be over solving quadratics. We're going to talk about solving by factoring as well as solving by using the quadratic formula. In addition, we're going to find a discriminant, which identifies the number and the type of solution. So for this first example, we have what's known as a difference of two squares because the first and the last term are square. You can take the square root of them. So that's what we're going to do. We're going to take the square root of the first term, and on the second term, you do not include that negative sign. Square root of 36 is 6, square root of x squared is x. And how do I know that? You take the exponent and divide it by the index, which is understood to be a 2. So 2 divided by 2 is 1. So that's how many x's can come out. On the other side, the square root of 49 is a positive and a negative 7 because 7 times 7 is not only 49, so it's negative 7 times negative 7. So that's why you have a plus and a minus 7. Now, once you take this information, excuse me, we're asked to solve by factoring, which means we're going to have some parentheses in our answer. So I take my first term, 6x, and then I place plus 7 with it. Now, the goal is whatever my answer is in factor form should end up being what I started with. So this is not what I started with. I have to continue. I go to my next set and I take another 6x, but this time I'm going to subtract 7. If I asked you to factor, then you would be finished. But I said to solve by factoring, which means you're going to set this equal to 0 and use the zero product property, which tells me to take each of my factors, I have 2, and set them equal to 0 to solve for x. Once I solve for x, that will tell me what makes this equation equal 0. And let's see if we even have the right factors. If I were to double check my work, 6 times 6 is 36. X times x is x squared. Check. And if I did the same for my last term, 7 times negative 7 is negative 49. So I know that I have the correct factors. Now I just have to finish the problem. 6x plus 7 is equal to 0, and 6x minus 7 is equal to 0. I want to subtract 7 on both sides because it's already positive, so I want to make it a 0. I'm left with 6x is equal to negative 7. Divide both sides by 6 because that's what's stopping x from being by itself. So one of my answers is negative 7 over 6. How many answers am I looking for? I always look at my exponent. So if my highest exponent is 2, I am looking for 2 answers. I told you in class that an easier way to find your x is to change the sign in front of your constant and then divide by the number that's in front of your x. So if we did that, if I change the constant, instead of negative 7, it will be a positive 7. And then divide that by what's in front of my x. Well, that would be 6. Those are my values for x. So x is the set of negative 7 over 6 and 7 over 6. Somebody's like, wait, whoa, how'd you get that? So let me just show you. What you're doing is the same thing. You're changing the sign because that's the inverse. And then you are dividing by what's in front of your x. It's just quicker to do it that way, to know what you're doing there. All right, so going to the next one, this is not a difference of 2 squares. First off, it does not have a difference, a minus sign. And secondly, that is not a perfect square, nor is that one. What it is something that I can factor out a greatest common factor. So what's the biggest number and possibly variable that I can divide both terms by? So I know it's 5 and x. Both numbers are divisible by 5, and I can take at least one x out. So by factoring, I am going to take 5x and then use my parentheses. What's left over? 10 divided by 5 is 2. If I started with 2 x's and I take 1 out, I'm left with 1. 45 divided by 5 is 9. If I start with 1x and I take 1 out, I am left with none. Again, if I was factoring, I would stop, but I'm not. I am solving. How do I know I'm solving? Because it has equals 0 to it. That means I'm going to use my zero product property, and I am going to set each factor equal to 0? Yes, greatest common factor. That's a factor. And then this is also a factor. So I have two factors. I'm setting them equal to 0. Zero product property tells me if I were to replace one of my factors with 0, it will equal 0. So 5 times 0 is just that. If I were to just mathematically show you what's being done, the work, it's still going to be 0. On the other side, change the sign of the constant, which will become -9, and divide by what's in front of your x. Those are my two answers. So x is the set of 0 and -9/2. Do not use parentheses because we're talking about two x's, okay? All right, let's go to the next one. We're still solving by factoring. However, it is not in standard form. So the first thing I want to do is I want to move this this 40 over by taking the inverse. And that's going to leave me with equal 0. That's what I'm trying to do. And I have 2x squared minus 2x minus 40. At this point, I want to see, can I divide everything by a greatest common factor? Yes, I can. Everything can be divided by 2. I do not have an x over here, so I cannot bring out a variable. If I'm putting it in factor form, whatever I just divided by, that goes outside of my parentheses. I am left with x squared. -2 divided by 2 is -x. And then -40 divided by 2 is -20. This is all set equal to 0. And I am going to try to factor some more. I can simplify that even further. So for me, I use the box method. You do not have to. My new first term is simply what's inside of the parentheses, x squared. My new last term is -20. So that's what I'm going to write in my boxes. I always have 4 boxes, the first term, the last term, and then I multiply my numbers. In front of my x squared is understood to be a 1. So 1 times -20 is -20. I'm looking for two factors that will multiply to give me that -20, but when I add, they give me -1. It's understood that there's a 1 there, but it is negative. So if I'm looking at I know 5 times 4. However, does 5 plus 4 give me -1? No. So that means I need to manipulate my signs. The rule is the bigger factor takes the sign of B. Well, B is the one that's in front of X. So whatever that sign is, that's what your bigger number takes. So it happens to be a negative. That's what this 5 is going to take on. So -5 times 4 does equal -20, and -5 plus 4 does equal -1. So I know those are my factors. It doesn't matter which goes where. I'm just going to put my two negatives on the same row. What does matter is that I do include the variable that is shown in the middle. I have to have that. And now in my next box, I'm going to have a plus 4x. And when I factor to the left, I'm just going to go ahead and take the sign that's closest to me. And the same thing when I go up, I'm going to take the sign that's closest to me so I won't forget which signs to take. When I'm looking at this, what is the biggest thing I can take out of both? I can take out an x, right? So that's my first greatest common factor. My next row, what is the biggest thing I can take out? Well, if I'm looking at my number 5, that's the biggest number I can divide it by. So then I want to check the next one. Can I divide 20 by 5? Yes, I can, but it said a negative. So I'm going to do a -5 with it, not just a 5, okay? Now going upward. If that part confused you, what you can do is ask yourself, x times what will give me x squared? And you should know that it's another x. Or you could have asked yourself, -5 times what will give me -5x? And again, it's still that x. -5 times what will give me -20? And you should know that it's a +4. And that again works for the top. X times what would give me +4x? Again, it's that +4. So I know that I am doing this correctly. So I have my factors, including the GCF, which in this case, it really doesn't matter because we're going to get rid of it. But if you were factoring, make a habit of bringing your greatest common factor down. That's part of your factor. So 2 times the quantity of x minus 5 times the quantity of x plus 4. If I was asking you to factor, but I'm asking you to solve because there's an equal 0, which is telling me to use my zero product property. So I'm going to set each factor equal to 0. Well, I know that's not true, so I'm going to have a slash on that one. You don't even have to do that part, but just so you can know that is part of your factors. And then I'm going to go to x minus 5, set that equal to 0, and x plus 4, set that equal to 0. Solving for x is always the opposite sign. So if I have -5, what will make that 0? +5. If I have a +4, what will make that 0? The opposite, -4. So those are my answers. X is the set of -4 and 5. Going on to the next section. This time we're going to solve by using the quadratic formula, and the formula is shown here. What you want to do is you have to always put your equation in standard form. So let's do that first. And what that requires us to do is to move this 7 over. So we're going to subtract 7 on both sides. And now we're left with 3n squared plus 10n minus 4 is equal to 0. So as long as it's equal to 0, we know we have it in standard form. Now let's identify our A, B, including a sign, and our C. Or you can write it A, B, C. A is 3, B is 10, and C is -4. I like to write it this way so that I can see the sign. Then you want to just input it in where you see that variable. So where it's asking for B, I'm going to put in a 10. Where it's asking for an A, I'm going to put in a 3. And finally, where it's asking for C, I will put in -4. Let's do that. X is equal to negative, and then use parentheses every time that you're substituting. If B was 10 a few minutes ago and a set of parentheses, guess what? It's still 10 because both represent B. So they should be exactly the same number. If they're not, you're doing something wrong. It's common for students to forget the plus or minus, so don't forget that. Minus your 4 is part of your quadratic formula, so it will always be a 4 there, or -4. And then A, you go back over here, is 3. And you want to multiply that times C, which is -4, all divided by 2 times A. Well, if A up here was 3, then guess what? It's still 3. So make sure that when you're looking at your input, 2 numbers should be the same for B, and 2 numbers should be the same for A. The only thing that's different is C. Make sure you have your signs. Now, if you have the scientific calculator, you can use your fraction button and input this information in, and it will give you your answer. Everybody else with the graphing calculator, we're going to manually do the math. So negative times 10 is -10 plus or minus the square root of 10 squared is 100. And then we have -4 times 3, which is -12. -12 times 4 is going to be +48. Now we have 2 times 3, which is 6. You can further simplify. So -10 plus or minus the square root of 148, all divided by 6. Again, keep going. -10 plus or minus. So we're going to take the square root of 148, and that gives us 2 radical 37, all divided by 6. Some people leave their answer in this form with a 1 big fraction bar. I don't. I separate mine. So I know this is 1 fraction, and I know that this is another. So I'm going to simplify by dividing both fractions by a 2. When I do that, I end up with a -5/3. Plus or minus goes in the middle. And then on this side, I have a 2/6. And if I'm dividing both of those by 2, that just leaves me with the radical 37/3. That's my final answer. So I can just say over here, x is equal to -5/3 plus or minus radical 37/3. And again, some people write one big fraction bar, and then they just have that 3 shown one time. So just know that if you see that on a standardized type test, it's not wrong. I just like to write mine in the form of a plus bi, plus or minus bi. And it just doesn't have an I in this case. It has a radical. Okay. Still using the quadratic formula. First thing I want to do is put this in standard form. So I'm going to subtract 4 on both sides, which leaves this to equal 0. That's what I'm looking for when I'm solving. 5n squared plus 4n plus 8. I can identify this as A, B, C, or I can write it to the side, A, B, C, and A is equal to 5, B is equal to 4, and C is equal to 8. Once I do set this up in the, let's go back up so you can see the formula. So I see that x is going to equal -b, which is 4, plus or minus that same b, but this time the b is squared, minus 4 times a, which is 5, and c, which is 8. All of that is divided by 2 times a. Okay, so now let's go ahead and make sure that everything is set up right. We have b. Yep, that looks good. We have A. Yep, that looks good. And we have C. So you definitely want to double check that. You hate to do all of that work and then you had it set up wrong. All right, so x is equal to -4 plus or minus the square root of 4 squared is 16. Pay attention to your signs. -4 times 5 is -20, and -20 times 8 is not positive. I just said pay attention to signs. -20 times 8 is -160. All of that is divided by 2 times 5, which is 10. So now I have -4 plus or minus the square root of, and if I do 16 minus 160, that is going to give us -144. All divided by 10. I can further simplify this. X is going to equal -4 plus or minus. Well, I see that this has an I, and I know that the square root of 144 is 12. So I have 12i that can come out from under the radical, all divided by 10. You can simplify this even further. I'm going to separate it into 2 fractions because that's my preferred method. And I'm going to divide both by 2, -2/5, plus or minus, and again, dividing this by 2, 6/5. And there's an imaginary part with it, which is I. So my answer is x is equal to -2/5 plus or minus 6/5i. 2 answers there. One is a plus, one is a minus. I just put them together. You could separate them using a set if you wanted to. And our last section is on the discriminant. Well, you should recognize this. This was the part that was under your quadratic formula. So this would be a discriminant. Once you actually do the math with just what's under it, do not take the square root. The part that is left under your that is your radicand, that is your discriminant. You have to do the same thing. You have to put it in standard form. So let's put this in standard form by moving the 6 over. So that's going to be a -6, which leaves that at a 0. So we have -3x squared plus 5x minus 8. Remember, if the signs are the same, you're adding and then you're taking that sign. At this point, you want to identify your A, B, and C. So A is equal to -3, B is +5, and C is -8. Just substitute it in the formula that's shown. That's your discriminant formula. Over to the side, I'm going to write 5 squared minus 4 times -3 times -8. And 5 squared is 25. -4 times -3 is +12. +12 times -8 is -96. So let's do our math here. And the math is going to be 25 minus 96, which is -71. So in addition to finding the discriminant, I'm also trying to find the number and type of solution. So this is my discriminant. So my answer to finding the discriminant is 71. What this means is if I were looking at this in my quadratic formula, like I said, under here, what's going to happen is I'm going to have an I. Well, I means imaginary. So when I'm asked, what's the number and type of solution, if I ever have a negative, or like if my answer is below 0 or it's a negative in front of it because that's below 0, that means I am always going to have 2 imaginary solutions because it's going to have an I that comes out in the answer. Another way that you may see this written is complex, so 2 complex solutions, or you may see non-real. It means the same thing. Those terms are interchangeable. And again, if I saw a negative discriminant, this is my discriminant, my answer is going to have an I in it. And you're going to have how many answers? You're going to have 2. One in this case was a positive, one was a negative. 2 imaginary solutions if you have a negative discriminant. Okay, let's go on to the next one. This one happens to already be set up as 0. So then all I have to do is identify my A, B, and C. A is -4, B is -9, and C is +9. Be very careful when your B, oops, I don't know how that happened, when your B is negative, because your formula, well, not here in the discriminant, but your formula for the quadratic formula would be, that's -b plus or minus if we're talking a quadratic formula. So the way that you would put that in is negative parentheses -9. Pay attention to that. Some people get thrown off by the negative sign there. So again, we're using a discriminant is b squared minus 4 times AC. So let's go ahead and substitute in. B is -9. And again, in the calculator, please, please, please put it in parentheses or it may not give you the right answer. 4 times -4 times +9. A negative times itself will always come out as a positive. So if your calculator is telling you -81, it's because you don't have your parentheses. All right, minus, okay, so here we have a -4 times a -4, which is a +16. And then we have 16 times 9, which is going to result in a +144. And when we add that to 81, that's going to be 225. Again, a discriminant is what is under the square root portion in your quadratic formula. You do not square root your discriminant. This is my discriminant. I'm finished there. But what I'm trying to tell you is this is a real number. It is not imaginary anymore. So when I am asked for my type of the number and type, if it is greater than, if my discriminant is greater than 0, meaning it is positive, then I'm going to have 2 real solutions this time. There will not be any I's in my answer. I'm going to have 2 real solutions. And then finally, if I had a situation like this, this is a +8. I don't know why I put a positive right there. I'm going to now move that over as a -8 so that I can put this in standard form. And that's going to be p squared plus 6p plus 9 is equal to 0. What I'm looking for again is my A, B, and C. A is going to be 1. It's understood there is a 1 right there. B is 6 and 9 is C. Using the same formula, the B squared minus 4AC, B is 6 squared minus 4 times A times C. 6 squared is 36, and negative 4 times 1 is negative 4. Negative 4 times 9 is negative 36. Well, if I ever get a 0, then my discriminant is 0. And this time I will only have one real solution. So the way I remember this one is I can only have one case where it's imaginary, and that's when it's like a negative. The other cases will be real. But how do I know how many? If it's 0, well, 0 looks like the O. So I know it goes with 1. That's how I remember it. So I hope that helped everybody to be prepared for this quiz that's coming up. I will do a test review at a later date, and I will also do the factoring calculator method for you all that who still need help with factoring using that calculator. Have an awesome day.